Hello guys, this is Mr. Jones again, of course, and we are doing reporting category 4, which is, as you see, all things quadratic. Quadratic functions we actually did well on those, so let's go ahead and get right into it. So the main thing, first thing went over were the attributes. So solutions are where it crosses the x-axis, so solutions are the x-intercepts, are also called roots and zeros. And you have your y-intercept, which we should know what that is, and we also have a axis of symmetry, which goes down the middle of the graph and goes through the vertex. Alright, this vertex, like it says, is a minimum because it's at the lowest point in the graph. This graph opens up, but your vertex can also be a maximum when your graph opens down, so both of these arrows are going down. Alright, we call our solution zeros because that's where y equals zero. So we're looking at this table, or any table, to find the solutions or your x-intercepts. You look at where y is 0. Just like if we were looking for the y-intercept, we look for where x is 0. Alright. Solutions, again, where it crosses the x-axis. So these are our two solutions at -4 and -2. Alright. So anytime you're trying to find solutions, you want to make the equation equal 0. We'll get that in a moment. So we have standard form. Standard form is just ax squared plus bx plus c. When looking at standard form, we didn't look at transformations from this form, but we can, as a matter of fact, we're not going to worry about that, but just know that this is standard form. Our transformations we looked at came in vertex form, where your vertex was h and k. Alright, so h, k, notice that h is the opposite, so whatever your h value, whatever is right here, your h is going to be the opposite. Your a caused a vertical stretch, and your k is a vertical shift, so up and down. Your h is a horizontal shift, and it goes in the opposite direction. So if I'm looking at my parent function, y equals x squared, and I'm going from that, zoom in a ski taste, to this, what are the transformations? So it is going to, one, it doesn't have a space for this, but it's going to open down because of that negative. All the negative tells you is what direction it opens. Opens down. And since it's going from 1 to 3, alright, remember, greater than 1, it's going to get narrower. Alright, it's going to shift to the right. Remember, this does the opposite, so it's going to shift right 1 unit and shift up 2 units. And then just looking at this, our vertex, remember, opposite of that value, so it's going to be 1, 2, 1, 2, 1, 2. We got that opposite here, and then it goes up 2. To enter, get our equation from a graph or in the calculator. Zoom out. We go to the same place where we put in our linear equations. Alright, so you go to y equal, turn on stat, edit, put your x values into L1 and your y values into L2. I already have that done. So you just put all those 3 points in. And then you would go to stat, calc. Remember, this is a quadratic regression. Alright. Now let's say we didn't know what it was, whether it was linear or quadratic. After I calculate, if it was linear, this square term would be 0. Alright, and your equation would just be this part right here. Alright, keep that in mind. But our equation today is y equals 2x squared minus 6x minus 20. All right. All right, next part, writing an equation given a point and the vertex. So this is kind of like when we're looking at linear equations and we got to write it given a slope and a vertex. I mean, not a vertex, a slope, and not even a slope and a point. Given 2 points. We're given 2 points, and we have to find the slope, just like we would have to do in a linear equation when we have 2 points. So you're going to plug everything into vertex form, your y, your x, your h, and your k. We have to find a. So we know this is h, this is k, this is x, and this is y. So we're going to write this down there. So our y, again, is 19, equals, we're trying to find a, and then x minus h squared plus k. And we just simplify that, so we got 19 equals a times 3 squared plus 1. You can subtract 1, subtract 1. 18 equals 3 squared is 9, so you can say a times 9, or if you want to reverse that and say 9a. Divide by 9, and we get a equals 2. So our equation is y equals 2 times x minus 5 squared plus 1. So all we want, once we have our equation, we just want to plug in our vertex and our a value, or our slope. Alright, so try that on this one. And call me over once you finish it. Domain for all quadratics, all real numbers, because this is extending to the left forever, to the right forever. Now it does not go up and down forever, so our range is not all real numbers, but we have to look at it whether it opens up or down. This one opens up, so it's going to be a number, x is going to, or y is going to be greater than some number, and that number is 1, 2, 3, 4, negative 4. So it starts at negative 4 and goes up, so everything is going to be greater than negative 4. And the last page, when we are solving, we're not going to do the quad because we didn't do quadratic formula. But if we want to solve this in the calculator, first we got to make it equal 0. So you're going to subtract 5 from both sides. Get 2x squared plus 4x plus 3 equals 0. And you're going to put left side in y1, right side in y2. So let's put this here. Clear. Right. 2x squared plus 4x plus 3. And then 0 in the y2. So make sure you do that part. Have to equal the quadratic, in order to solve it, has to equal 0. Then we go to second, well, first graph it, because we're gonna graph 2 lines. Boom, boom. And first thing you should immediately notice is this doesn't cross the x-axis. And even if you don't notice and you try to calculate where it intersects, thinking no sign change. So there, it doesn't touch that line, so there's no solution. So your solution is again where it crosses the x-axis. Make sure I entered that right. See if I in fact have. So I subtracted 5. Yep. So everything's right. Again, we didn't do quadratic formula, so we're not going to worry about that. And that wraps up reporting category 4.